P effective. This is the actual wormhole shape function, which includes the charge. This is the density function, and the other relations we get easily. The pressure. This is the dark energy density and dark energy radial pressure, dark energy tangential pressure. This is a very big expression, and now we try to find the wormhole figures. For n is equal to half, we have considered n equal to half. Actually, q square equal to 0.1 we have considered because of geometric units only. These are not natural units, but we can convert it into natural units also. Here RS is the characteristic scale length. This is the shape function of the wormhole, which we have obtained, and the throat should occur always where Bn minus R cuts the R axis. These are plotted against R in kilo per kpc. Next we also find that B at R0 should be equal to R0. This is one clear condition. Second is B dash at that particular point should be less than 1. That condition is also satisfied. So we find that the throat of the wormhole, throat is the minimum radius through which the traveler can traverse, minimum radius. So using these conditions we find ER, the electric field is also plotted against R. Next we find this is the velocity profile, which satisfies with the other experimental observational results, which is also shown. Next, L is actually a parameter, which this L is actually a parameter which we have also plotted against R. Now, this is the profile curve of wormhole. Actually, J function of R. This is actually the profile curve. If we rotate this shape function about the Z axis, we will get the figure of the wormhole. So this we have done. Actually, here we find the get actually two wormholes. One wormhole lies between 0.9092 to 2 kpc, and the second is beyond that one. So, and there is another thing. LR is called proper length. This should be finite. It varies from minus infinity to plus infinity. Just like T varies from minus infinity to plus infinity. This proper radial distance from the throat, that is R0, the throat we have found 0.90 to R. We study this, we find to be positive. We study the geodesic equation of test particles. Here we find that d square and d square is negative. Means there is a centripetal force towards the center, which also satisfies the observational phenomena pertaining to gravity on the galactic scale, which is attractive. Next slide, the TOV equation. This is the Tolman-Oppenheimer-Volkov equation, which stands for the anisotropic. This is PT minus V. This third one is the anisotropic field. Last one is the electric. Sorry, these are the four forces: gravitational, hydrostatic, anisotropic, and electric. So if the sum of if the system is in equilibrium, the sum of the forces should be equal to 0. So we have tried to plot these four forces, and we find that the anisotropic force is balanced by the other three forces, and the system is in equilibrium. The figure 34 also that gives the proper charge density, 34 equation. Now we find the effective mass from the throat up to 10 kpc. We find it to be positive. Hence, if a person is seeing from the art, he cannot distinguish whether it is a wormhole or a compact mass. Just like a black hole, there is even horizon we cannot see what is inside, but wormhole it can be seen as a compact mass. Now there are certain energy conditions, that weak energy condition, low energy condition, strong energy conditions. One of the conditions should be violated in wormholes. In astrophysical objects, all the conditions should be obeyed, but if any of all of them is violated, then that is definitely a wormhole. Here we find that null energy condition, which is rho plus p less than 0, this condition is violated, so it can be a wormhole. These are the two regions. In the first region we find rho plus p less than 0, and the second rho plus p tends to 0 as r tends to infinity. So actually we get two wormholes. Now we test these in the galactic halo region, which obeys this density profile. We put this rho r in our equation, and we find the step function of the wormhole. We get the value of q, And here we find that B is an increasing function, the frequency of the wormhole, which satisfies the wormhole figures. Br by R should tend to 0, and the throat will occur at the region where Br minus R touches the R axis. Here we find that the throat occurs at this point, 3.0819. Actually, it is an image in KPC only. Next, the results we try to find whether it can be, our metric can be generalized to study slow wormhole rotating cases also, and we find that it can be done also. Hence, it can be used to the self-sustained static wormhole metric. The second one is that whether it can be traversable or not. We are trying to reduce it using the fifth coordinate Z and reduce it as the metric equation in 48 and find that yes, it can be traversable wormhole also. So the dark matter and dark energy may lead to the violation of null energy condition and to the formation of configuration with non-trivial topology like a wormhole. So this thing we have obtained. Also dark energy omega should be less than -1, and so our metric is valid. Again, another thing is that whatever be the wormhole throat, the charge will have no effect. We iterate that such a metric is useful for wormhole study in other regions of the galaxy and different forms of gravity as well. These are the references.
Thank you for being perfect on time. Okay, so any questions for our speaker? Yes.
You lost me on the math, I think, the second slide. But despite that, why are you considering dark energy at all in your equations? Wormhole is a collapsed object, right?
Yes.
The contribution of dark energy in a collapsed object is 0 if the dark energy cannot cluster. So why bother?
Actually, we have also tried that dark energy present today when expansion of the universe is responsible because of dark energy only.
Yeah, but in your metric, when you are in a collapsed object, collapsed object like a small closed universe will collapse on itself.
No, it has not yet collapsed. If it is collapsed, then it is a black hole. So it is.
Yeah, but it's a collapse.
It has a mass. It has no singularity.
Yeah, but it's a collapsed object. I mean, it's not background density. You say it would be a star, right? The density is very high in the wormhole.
No, inside I think we have the mass should be from the wormhole throat because if there is mass, how can we go to the outer side? The mass is from throat radius. No, not I think it is from throat radius.
Yeah, if it's an object, I don't get.
What's it is not an object. It will seem as if it is a compact object from the outer side.
Yeah, we cannot like a compact object. Dark energy is negligible. In a galaxy, dark energy is negligible.
But we have considered the fluid content to be real matter and dark matter. That reason.
I don't get why you have dark energy in your matrix. I don't get it.
No, I consider.
You have rho d. You had it. Right?
Yes, I consider. So it is not isotopic. It is anisotopic because of these two types of fluid. One is real matter and it is dark matter.
Okay, so it looks like it's. Okay, so you may continue this.
Yeah.
Yes.
In this slide, actually, you skipped one of the slides, but I managed to notice that you used Lambert W functions, right, in your equations.
Which are
Lambert W function.
yes, sir. That is just I consider as a parallel.
Yeah, you think it's technical, so you skipped it, right?
Yes, that has no relevance actually.
But it appears naturally, you say.
Yes, because it appeared in that velocity profile, so I tried to just put it as a function. It has actually no specific loading one.
No, but from my point of view, W functions is Lambert W functions.
Yes.
It's coming back from oblivion. More and more people use it over and over again.
Okay, other questions? Okay, so let's thank our speaker again. Thank you for being here, and this is the end of this session. Thank you.